Welcome to Aeronet's visual simulation training program for the Airbus A320. The CFM 56-5A engine mounted on the A320 is a high bypass turbofan engine producing 25,000 pounds of thrust at sea level. It is produced by CFM International, a joint venture between SNECMA of France and GE Aircraft Engines of the USA. The engine core, based on the GE F101 engine installed on the Rockwell B-1B bomber, is manufactured in Cincinnati, and the low-pressure system is manufactured by SNECMA in Villaroche, France, where final assembly takes place. The bypass ratio is 6.2 to 1. Approximately 80% of the thrust is produced by the 71.5-inch diameter fan, and the remaining 20% of the thrust is produced by the engine core. The engine weighs approximately 5,000 pounds. A pylon attached to the wing supports the engine by 2 mounts, each secured to the engine by 4 bolts. The engine is enclosed by cowls that ensure the proper flow of air around the engine while protecting the engine and its accessories. Lightning protection is provided by using a conductive graphite material within the cowl skin. Reverse thrust is achieved by the positioning of 4 pivoting blocker doors that redirect the fan air forward. The CFM56 engine is comprised of 4 primary modules: the fan and low-pressure compressor, the high-pressure compressor, combustion chamber, and high-pressure turbine, the low-pressure turbine, and the accessory gearbox. The low-pressure, or N1 rotor, consists of a single-stage front fan and a 3-stage low-pressure compressor, which supercharges the inner portion of the fan airflow. They are driven by a 4-stage low-pressure turbine connected by the fan shaft. 4 stages of stator vanes are installed within the compressor section. The design of the spinner cone mounted on the front of the fan prevents the need for engine nose anti-icing. The high-pressure, or N2 rotor, consists of a 9-stage high-pressure compressor driven by a single-stage high-pressure turbine. Compression is progressive as air passes through the successive stages of the compressor blades. The annular combustion chamber is located between the high-pressure compressor and the high-pressure turbine and is fitted with 20 fuel nozzles and 2 igniters. The accessory gearbox, located below the fan case, is driven by the N2 rotor through a system of shafts and gears and provides mechanical power to engine-mounted accessories, including the hydraulic pump, fuel pump, engine generator, Fedex generator, and starter unit. Drain lines and collectors are installed to collect and carry waste fluids and vapors from areas around the engine that may leak and deliver them overboard through the drain mast located at the bottom of the cowling. Some fluids are discharged immediately, others are contained in a holding tank and discharged in flight when the aircraft speed reaches 200 knots. Each engine is equipped with a Full Authority Digital Engine Control System, or Fedex, which manages all aspects of engine thrust and controls the engine start sequence. The thrust levers are located on the center pedestal. The thrust lever control system is fully electrical. There is no direct mechanical linkage to the engines. Each thrust lever is also fitted with a reverse latching lever and an auto thrust instinctive disconnect push button. The engine control panel, located aft of the thrust levers on the center pedestal, includes the engine mode selector, the engine master switches, and the fire and fault lights. The engine manual start panel, located on the overhead panel, is used to start the engines when an automatic start is not possible, or for dry cranking of the engine. The engine Fedex ground power panel, located on the overhead maintenance panel, is used for maintenance purposes only to supply the Fedex with electrical power when the engines are shut down on the ground. The auto thrust push button switch is located on the glare shield FCU panel. It allows the pilot to arm or deactivate the auto thrust and indicates when the auto thrust is armed or activated. The upper ECAM permanently displays the engine primary parameters to the flight crew. The secondary engine parameters are displayed on the lower ECAM engine page either automatically during engine start, when takeoff power is selected, and with certain engine faults. The ECAM engine page can also be selected at any time by the crew on the ECAM control panel. Fuel used, oil quantity, and vibration indications are repeated on the ECAM cruise page. Fedex, or Full Authority Digital Engine Control, provides a full range of engine control, manages engine starting and thrust, and optimizes engine operation. The Fedex system consists of a dual-channel electronic control unit, or ECU, mounted on the engine and a number of peripherals. The EIU, or Engine Interface Unit, located in the avionics bay, is the interface between cockpit controls and the Fedex. Fedex automatically computes thrust parameter limits and displays them on the upper ECAM depending on thrust lever position. These parameter limits are max takeoff and go around, or TOGA, flexible takeoff, or flex, max continuous, or MCT, climb, and max reverse. Engine limit protection is provided through the use of governors preventing N1 and N2 from exceeding computed values. Fedex adjusts the fuel flow to achieve the requested N1 as a function of two thrust modes. Manual mode, with auto thrust off, depends on thrust lever angle. And automatic mode, with auto thrust on, depends on demands generated by the auto flight system. Two takeoff power settings are available. If it is determined that a reduced thrust takeoff is possible, a flex temperature is entered into the performance takeoff page of the MCDU, and the thrust levers are advanced to the flex detent. If a full power takeoff is desired, the flex temperature field is left blank, and the thrust levers are positioned fully forward to the toga stop. Fedex also provides for two idle mode schedules: minimum idle, which varies depending on air conditioning and anti-icing demands, and approach idle, obtained when the slats are extended, allows for faster engine spool-up should a go-around be necessary. Fedex controls thrust reverser blocker doors actuation and thrust setting during reverser operation. Fedex controls the automatic start sequence by monitoring N1, N2, fuel flow, and EGT, and can abort or recycle an engine start. It also monitors the manual start sequence, but does not provide the same measure of control. When the aircraft is first powered up, Fedex is supplied with aircraft system power for 5 minutes, performs a self-test, and then shuts down. During engine start, when the ignition start switch is selected to ignition, Fedex is again powered by the aircraft electrical system. However, when N2 reaches 12%, Fedex is supplied directly by its own dedicated electrical generator mounted on the accessory gearbox. The thrust lever is used either manually as a conventional thrust setting lever or automatically as a thrust limit selector, depending on where the thrust lever is positioned and whether the auto thrust is active. When auto thrust is active, the thrust levers remain fixed and do not move as engine thrust varies. On takeoff, auto thrust is armed automatically through the FMGC when the thrust levers are set to the flex or toga position. The green light illuminates on the auto thrust push button located on the FCU, and the cyan auto thrust message appears in the right-hand column of the FMA. Auto thrust becomes active when at the acceleration altitude, normally 1,500 feet, the thrust levers are selected to the climb detent with both engines operating, or to the MCT detent when only one engine is operating. This is indicated by the auto thrust message on the FMA turning white. In flight, with both engines running, setting the thrust levers forward of the climb detent deactivates the auto thrust, but it remains armed. The auto thrust message on the FMA changes to cyan. Auto thrust is reactivated as soon as the thrust levers are set back to the climb detent, as indicated by the white auto thrust message. With auto thrust active, the Flight Management Guidance Computer, or FMGC, computes the thrust required according to the demands from the MCDU and/or the FCU, then transmits this data to Fedex via the FCU. Fedex then controls the fuel flow in order to achieve the desired N1. The thrust lever acts only as an N1 upper limit, which Fedex computes and displays on the upper ECAM. These limits are climb, with both engines operating, and MCT with one engine inoperative. The auto thrust can be disconnected by pushing an auto thrust instinctive disconnect push button located on the sides of the thrust levers, setting both thrust levers to the idle detent, or by depressing the auto thrust push button located on the FCU glare shield panel. Caution: if the instinctive disconnect push button is held for more than 15 seconds, the auto thrust system is disconnected for the remainder of the flight. When the auto thrust is disconnected with the auto thrust push button on the FCU or with the instinctive disconnect push button, the amber thrust lock message flashes in the first column of the FMA. The thrust is locked at its current setting and will not change until the thrust levers are moved out of the climb detent. In the manual mode, the thrust levers operate indirect thrust control. The thrust control system is in the manual mode when the auto thrust is deactivated or is armed but not active because the thrust levers are not in the auto thrust operating range. The N1 command is computed by Fedex according to the thrust lever angle set by the pilot. The N1 rating limit, displayed on the upper ECAM, is that corresponding to the next upper detent point. For example, with the thrust lever set midway between idle and climb, the N1 limit display is climb. With the thrust lever set midway between climb and MCT, the N1 limit displayed is MCT. The small white circle or donut on the top of the N1 indicator shows the actual position of the thrust lever and is visible with and without the auto thrust on. The blue N1 transient arc shows the difference between the actual N1 and the commanded N1 as the engine spools up or down to match the desired setting. It is visible only when the auto thrust is on. To obtain reverse thrust settings, the thrust lever must be in the idle position and the thrust reverse latching lever must be lifted, allowing the thrust lever to move into the reverse thrust range. Reverse thrust can be modulated from idle to full reverse. The engine fuel system is designed to provide fuel to the engine combustion chamber, the IDG cooling system, and to the actuators of the compressor flow control and rotor blade clearance systems, which will be covered later. The fuel pump assembly is mounted on the accessory gearbox. Fuel destined for the combustion chamber travels from the aircraft fuel tanks through the low-pressure shutoff valve into the low-pressure stage of the main fuel pump, through a fuel oil heat exchanger where it cools hot engine oil, then into the high-pressure stage of the fuel pump. It then flows into the hydromechanical unit, or HMU, where it passes through the high-pressure shutoff valve and to the burner nozzles. The hydromechanical unit controls fuel flow to the combustion chamber by means of a burner staging valve, or BSV. The BSV delivers fuel to either all 20 fuel nozzles or to every other nozzle as commanded by Fedex. 10 fuel nozzles are always on, but for takeoff and other high-power operations, all 20 fuel nozzles are utilized. Fuel flow is displayed on the upper ECAM in pounds per hour. Fuel used is displayed at the top of the engine page and is repeated on the cruise page. The figure is reset the next time the engine is started on the ground. The fuel filter clog indication appears in amber if the fuel filter becomes clogged. The oil system lubricates the engine components and includes an oil supply system and oil scavenge system. Oil from the tank passes through a supply pump and filter and lubricates the forward and aft bearings and the accessory and transfer gearboxes. Oil returns to the oil tank by means of 4 scavenge pumps protected by strainers and chip detectors and is cooled by the fuel oil heat exchangers. The oil flow rate at takeoff is over 43 quarts per minute. The max oil consumption is 1.6 quarts per hour, enabling the engine to operate for approximately 16 flight hours. Oil system indications are displayed on the ECAM engine page. Oil quantity, displayed in green, pulses when quantity drops below 3 quarts. Oil quantity only is also displayed on the ECAM cruise page. Fedex provides for engine optimization by controlling compressor airflow through the use of variable bleed valves and variable stator vanes. At low engine RPM, the compressor provides more air than the engine can utilize, so the 12 variable bleed valves, actuated through the HMU, open to discharge excess air back into the fan air stream. The variable bleed valves close as N2 increases. The angle of the inlet guide vane and the first 3 stator vanes of the high-pressure compressor are variable to optimize performance and provide adequate stall margin over a wide range of operating conditions. The vanes are positioned by HMU-operated actuators controlled by Fedex. As N2 increases, the variable stator vanes open to allow a greater airflow through the compressor. 3 systems control and adjust the clearance between the rotor blades and stator casing. This improves efficiency and reduces fuel flow and EGT. These are the rotor active clearance control system, the high-pressure turbine clearance control system, and the low-pressure turbine clearance control system. Each is controlled by Fedex and is actuated with fuel hydraulic pressure provided by the HMU. Rotor active clearance control is achieved by directing hot 5th stage high-pressure compressor air into the high-pressure compressor rotor cavity, which causes the rotor blades to expand and reduces clearances between the blades and the casing. It becomes active above 8,000 feet in order to prevent blade tip rub at takeoff. The high-pressure turbine clearance control system uses 5th and 9th stage bleed air to control thermal expansion of the high-pressure turbine shroud in order to optimize blade tip clearances and maximize high-pressure turbine performance. The low-pressure turbine clearance control system optimizes low-pressure turbine clearances above 10,000 feet by allowing cool fan air into the perforated cooling manifold surrounding the low-pressure turbine casing. In flight, the ECU is cooled by air entering the fan casing through a scoop on the engine cowl. The air is then exhausted overboard. On the ground, where there is no ram air effect, cooling airflow is provided by means of a jet pump supplied with pneumatic air from the starter duct, which is always pressurized when the engine is running. The engine nacelle compartment cooling system provides airflow to offset the effects of combustion compartment heating and for the cooling of engine-mounted accessories. The fan compartment has a flush air inlet on the lower portion of the fan cowl. Air enters the inlet, passes around the accessory gearbox area, and is then vented overboard. The hot core compartment is cooled with fan discharge air taken in by 4 flush inlets installed in the core cowl. A nacelle temperature sensor installed near the forward engine mount measures the fan compartment temperature. It can indicate an overheat condition due to loose or broken air ducts. The measurement range is -55 to +300 degrees and pulses green as an advisory only when the nacelle temperature reaches 240 degrees. The ECAM engine page automatically displays when this occurs. The thrust reverser system utilizes hydraulic power from its respective hydraulic pump mounted on the engine. A hydraulic control unit, or HCU, controlled by Fedex, positions 4 pivoting blocker doors that redirect the fan air forward. The aircraft must be on the ground and the engine must be running. When reverse thrust is selected, Fedex sends a signal to the HCU, which sends hydraulic pressure to the unlock side of the blocker door latches, then to the deploy side of the blocker door actuators. Each door operation is independent of the others and takes less than 2 seconds to deploy. Touch the thrust levers to select reverse thrust. During the deployment sequence, as soon as the first pivoting door opens, the amber reverse indication is displayed on the N1 indicator. When all 4 doors have reached 95% of their full travel, the reverse indication changes to green. Hydraulic pressure is then released from the system. During the stow sequence, the HCU sends hydraulic pressure to the retract side of the door actuators. When the first blocker door begins to close, the reverse indication changes to amber. When all doors are closed, the reverse indication disappears. Fedex controls the ignition system, utilizing 2 igniter boxes per engine to convert 115-volt AC power into high-voltage energy for engine starting and for engine flame-out protection. During an automatic start, only 1 igniter fires, and Fedex alternates igniters used on successive starts. Ignition comes on when N2 reaches 16% and cuts off when N2 reaches 50%. During a manual start, both igniters fire when the master switch is placed to on, and they stop when N2 reaches 50%.
Continuous ignition is automatically selected on when the engine anti-ice is turned on, an engine flameout is detected, or the engine interface unit fails. Ignition may be manually selected on by placing the engine mode selector to ignition.
The engine start system consists of a start valve, an air starter, 2 ignition boxes, and 2 igniters A and B. Pneumatic air for starting is provided by the APU, a ground pneumatic start unit, or in the case of a crossbleed start, by the other operating engine. If there is an electrical fault in the start valve, a manual override handle allows a ground crewman to operate the valve manually. The starter uses the same drive gear system as the accessory gearbox, only in reverse. Air from the start duct turns the starter turbine, which in turn drives the N2 rotor through the accessory gearbox driveshaft. At 50% N2, the centrifugal clutch disengages. If the clutch fails to disengage, cutter pins inside the starter unit will cut the rim from the turbine wheel containing the parts within the starter unit. There are 2 start modes, automatic and manual. For an automatic start, Fedex has full authority over the start valve, ignition, and fuel, and will abort the start in the case of start valve failure, starter engagement time limit, ignition failure, HP fuel shutoff valve failure, high EGT, engine stall, hung start, overspeed, or no light up. Select the engine mode selector to ignition start. Then after all amber X's have disappeared from the upper ECAM, indicating that Fedex has powered up, place the master switch to on. Start fault messages are generated to the ECAM. The amber fault light on the engine control panel also illuminates if a fault is detected or if there is a disagreement between the high-pressure shutoff valve and the master switch. When a start fault is detected, Fedex will crank the engine to clear out any fuel vapors, then control any additional start attempts if allowed. Up to 3 additional starts will be attempted depending on the fault. The automatic start sequence can be interrupted at any time by placing the master switch to off. Note, once the master switch has been placed to on, selecting the engine mode selector from ignition start to norm has no effect on the start sequence. For an in-flight start, Fedex determines whether the engine is windmilling fast enough or needs assistance from the starter. Both igniters are activated. In the event of an abnormal start, fault warnings are generated, but Fedex does not automatically abort the starting sequence. If an automatic start has been aborted due to engine stall, high EGT, or low start air pressure, or if it is anticipated that start pressure will be marginal due to hot or high conditions, use the manual starting procedure. A manual start is accomplished by selecting ignition start on the engine mode selector. The ECAM engine page appears. After all amber X's on the upper ECAM page disappear, select the manual start push button switch to on. the start valve opens. At 20% N2, the master switch is placed to on, and ignition and fuel are introduced. When N2 reaches 50%, the start valve closes and the ignition goes off. The engine manual start push button is then selected off. After the second engine is started, the engine mode selector is selected back to norm. During a manual start sequence, Fedex monitors start parameters and generates abnormal start messages to ECAM. The crew must take the appropriate actions to abort the start. The only exception is if the start EGT is exceeded before 50% N2. In this case, Fedex aborts the start. The crew interrupts a manual start before the master switch is placed to on by switching the manual start push button switch to off. After the master switch has been placed to on, the start is aborted by switching the manual start push button switch to off and then placing the master switch to off. Dry cranking allows the crew to ventilate the engine to remove fuel vapors after an unsuccessful start attempt. The engine mode selector is set to crank and the manual start push button is set to on. Do not re-engage the starter when N2 is greater than 20%. Takeoff and go-around thrust is limited to 5 minutes, except with an engine failure, the time limit is 10 minutes. The max EGT for takeoff and go-around is 890 degrees. The max EGT for max continuous and climb thrust is 855 degrees. The max EGT for starting is 725 degrees. The max continuous oil temperature is 140 degrees. 155 degrees is allowed for 15 minutes max. The minimum starting oil temperature is -40 degrees. For oil pressure and oil quantity limitations, see FCOM 3. The maximum N1 is 102%. The maximum N2 is 105%. 4 consecutive start cycles are allowed, each with a 2-minute maximum duration. 20 seconds must be given between start cycles to allow for starter lubrication. After 4 cycles, 15 minutes must be given to allow for starter cooling. Do not engage the starter when N2 is greater than 20%. Attempting to select reverse in flight is prohibited. Backing up of the aircraft is also prohibited. Max reverse thrust should not be used below 70 knots. Reduced thrust takeoffs are not permitted on contaminated runways, or with one or more thrust reversers inoperative, or with any other inoperative system such as brakes or anti-skid, which may affect stopping performance. Refer to the MEL. During the configuration safety check, confirm the master switches are off and the engine mode selector is set to norm. During the cockpit geographic check, check that the engine manual start panel switches are guarded and the lights are out. On the lower ECAM display, confirm the engine oil quantities are sufficient for flight. Confirm the thrust levers are at idle, the engine master switches are off, and the engine mode selector is in the norm position.
When ready to start, select the engine mode selector to Ignition Start and confirm the amber X's have disappeared on the upper ECAM to indicate Fedex has powered up.
Before takeoff, if it is desired to use a flex takeoff procedure, confirm that a flex temperature has been entered into the MCDU perf page. Before takeoff, select the engine mode selector to ignition if there is heavy rain, standing water or snow on the runway, or heavy rain or severe turbulence is expected after takeoff. When ready for takeoff, advance the thrust levers to approximately 50% N1. Allow the engines to stabilize together, then smoothly advance the thrust levers to the flex or toga detent. Confirm that flex or toga is enunciated on the FMA and that auto thrust is displayed in cyan to indicate it is armed. Any change to the FMA will be boxed in white for a period of 10 seconds. Prior to 80 knots, confirm that the commanded N1s have been achieved on the N1 indicators. When the acceleration altitude has been reached, normally 1,500 feet, climb will flash in amber on the FMA. Bring the thrust levers back to the climb detent and observe that the FMA indicates climb. The auto thrust, which was armed when the thrust levers were placed in the flex or toga position, will now become active as indicated by the white auto thrust message in the right-hand column of the FMA. As long as the aircraft is climbing unrestricted, the thrust achieved will be max climb thrust. When the cruise altitude is reached, the auto thrust system will vary the N1s to maintain the desired cruising speed as determined by the FMGC or the pilot through the FCU. The thrust levers are left in the climb detent, acting only as an N1 upper limiter. When the aircraft descends, again the thrust levers are left in the climb detent. In an unrestricted open descent, the thrust is reduced to idle, but the thrust levers do not move. If an intermediate level off is required, the power increases to maintain the altitude and airspeed, and the auto thrust system uses the thrust lever position as an upper N1 limit. At 20 feet, the auto call-out system asks the pilot to retard the thrust levers during flare.
Retard.
Pull the thrust levers back to the idle position. When the main landing gear is firmly on the runway, raise the reverse latching levers and move the thrust levers into the reverse operating range. On the N1 indicators, the amber reverse indication appears, indicating that the reverser blocker doors are in transit. When the doors are open, the reverse indication turns to green. At approximately 80 knots, Move the thrust levers to the reverse idle position, pausing momentarily to allow the engines to spool down. Then, push the thrust levers forward to cancel reverse and return them to the forward idle position. On shutdown, ensure at least 3 minutes of engine operation at idle if max reverse thrust was used. Then once APU or external power is available, select the engine master switches to off.
With a tailpipe fire on the A320, the engine must be shut down. The procedure is not displayed on ECAM, but can be found in the QRH and FCOM3 abnormal and emergency procedures. Do not press the engine fire switch, since this would cut off power to Fedex and prevent dry cranking of the engine. Select the engine mode selector to crank, the manual start switch to on, and motor the engine for at least 30 seconds, or until the burning has stopped, whichever is later. Call maintenance and inspect the engine for damage.
At takeoff, if the pilot inadvertently sets the thrust levers to the flex position without having set a flex temperature into the MCDU performance page, this warning is triggered. Simply push the thrust levers to the toga position and continue with the takeoff. Touch the thrust levers to select toga thrust. An oil temperature between 140 degrees and 155 degrees for more than 15 minutes, or above 155 degrees, triggers this warning. In addition, the digital temperature indication turns amber. Shut down the engine. In addition to an engine oil pressure transmitter, which sends oil pressure information to ECAM, there's a low oil pressure switch set at 13 psi, which activates the master warning and the low oil pressure warning. ECAM asks that you check the oil pressure gauge to confirm that the oil pressure is less than 13 psi, and if confirmed, calls for the engine shutdown procedure. If the oil pressure is normal, consider a faulty low oil pressure switch. Anytime at least one reverser door inadvertently opens, Fedex automatically commands the restow function. If a door remains open, the engine is also set to idle as indicated on ECAM. If buffet is felt, limit airspeed to 240 knots, then shut the engine down. Touch the right arrow to continue. Each thrust lever is connected to a dual-channel sensor or resolver located below the center pedestal. When the two channels disagree, this warning is displayed. On the ground, Fedex automatically selects idle power. In flight, with takeoff power selected, Fedex maintains takeoff power, either flex or toga, until thrust is reduced, after which the maximum power available will be MCT. With the auto thrust on, thrust will be managed between idle and the actual thrust lever angle. Clear engine 1 by pressing the clear button on the ECAM control panel. With the failure of both thrust lever resolvers, no valid thrust lever angle information is available, so Fedex automatically selects idle thrust on the ground. In flight, the auto thrust will manage thrust, so keep it on. Clear engine 1 by pressing the clear button on the ECAM control panel. Again, it is suggested to use auto land, otherwise the engine would have to be shut down at 500 feet AGL. Clear status by pressing the clear button on the ECAM control panel. A number of non-normal ECAM messages appear that only require crew awareness. Refer to FCOM 3, Abnormal and Emergency Procedures.